Aloha, Rich Alverson here, and this is ITS128. And we're in our third week. And today I'm going to go over, I guess, chapter 3. Let me share my screen. Okay. 120. Okay, so we are in chapter 3, and I guess we got some lab activities. So let's see if I can get through those. I should mention on the weekly engagement thing. You know, that really is for me, in case you drop. Now, you know, I mean, probably none of you will drop. Well, maybe one or two of you will drop. So it's not going to matter to you, but when somebody does drop, I have to say the last time I saw them or had the last time the person was engaged in the class, and that's all that is. So the answer can be, it says, what did you learn? As long as that's the question, what did you learn this week? Or the question is the way it is now. You can say nothing. You can type nothing if you want to. A family emergency came up and you weren't able to get to the class at all. That's perfectly fine. That counts. And so I have, you know, so you can miss 6 of them, and but I needed to have something there to get you to do it. So that's why there's some points there. So anyway, let's see. Do I need to talk about what's in the resources? Okay, these are the playlists from previous semesters, and our playlists are going here, and it looks like I've uploaded a bunch of chapter 2 labs. All right, so I've got 4 classes, and they're all using zyBooks. And I'm teaching this other ITS128, which is a Java programming, and I'm using the Java version of this textbook. You know, we're using the Python version, and in the other class I'm using the Java version, and so it's just that we're going a little faster in the other one. But so there may be times when I think that I covered something, but I really didn't. So if that ever happens, you can, you know, let me know. All right. So if we look at the textbook, and we're in chapter 3. So is this yeah, I think I can. You can click right here. Chapter 3, types. All right, so this is ITS128. So there are okay, I also want to make sure that I cover all the challenge activities. So I've got my instructor version right here, and I want to pop open the reporting of chapter 3. Okay. Oh geez, there's challenge exercise. Challenges in every section. No, wait, oops. No, in most sections. Okay, so so there's you know, in Python we have these variables, and variables are like containers that can store numbers or store data, and they can either store a string of characters, which is like a sentence or a word, or it can store an integer number, which is a whole number. Doesn't have to worry about, you know, fractions, and then it can also store numbers that have a decimal point. These are all different kinds of basic types of data that Python stores, and all languages are similar in this case. So we're with strings, we're going to talk about strings now today, and strings have some special properties, some special things that you can do. a string is a sequence of characters, and Python provides a nice way to access substrings by just identifying the beginning point and the beginning character, the index of the beginning character, and the index of the ending character. And we're going to see that. See, what is this? This is here. This is just for reading in some words and outputting a little story sentence that we create here. Anyway, so here we're trying to identify string literals, and string literals, of course, are always surrounded in quotes. So this is a string literal. This is a string literal. This is not a string literal. This is an actual number where if you add 5 to it, it's going to end up being 679. So no, this is not a string literal, but this is. Why? Because it has the asterisks, the single quotes. And if you use a plus sign and try to add something to it, it has to be another string, and it's going to be concatenating the string onto the end of the string, and not somehow calculating, not how somehow interpreting it as a value, and you add 5 to it, and it changes this to a 9. This is a string because it's quotes. It can be single quotes or double quotes. You just have to be consistent. If you start out with single quotes, it's got to end with a single quote. Same with double quotes. So go through this. This is not which answer creates a string variable first name that has the value of this string. Well, when you're assigning a value, the thing that is taking in the value that you're assigning is on the left side, and then the right side is what's evaluated and calculated, and all. Here it's just defining a literal. Here it's just a literal, and that gets stored into this variable. So that's what's going on here. So it's this one. This one won't work because this is not a literal. It's got to be quotes. It's got to have quotes. This is the Python interpreter would interpret that as another variable, and then it would give you an error because that variable hasn't been defined. And the first time you use the variable, it's on the right side, and that's a no-no, because for it to be on the right side, it would have to at first be on the left side. You have to assign a value to it before you can use it. Anyway, I hope that made some sense, but it'll be clear to you, if not this week, in the next couple of weeks. Okay, so here talks about you can access individual characters of a string. So let's say you have this variable and you store this literal string into it. So it's these 26 characters. And then if you just wanted to print the character at index 0, or you want to print the character at index 1, which would be a B, or you want to print the character at index 25, which would be Z. Start counting at 0, so it's 0 to 25. So that's this indexing. And of course, what you're using to index it doesn't need to be an integer itself. It just needs to evaluate to an integer. So since user number is an integer, its user number is a variable that is holding an integer. So then you can use it as an integer, and that's what you're doing here. You're referring to, or you're referencing that number character. So do we run this? Okay, so this is the input. Okay, so what is the 12th character? What's the 12th character? It's going to be the character at index 12. the letter at index 12, which is actually, so it's actually going to be the 13th character. Okay, so. All right. I don't know why my chat window is so big. All right. All right, let's find some challenges. Okay, here's a challenge. Type the program's output. CID, enter. Okay, I'm gonna do a harder one. 5. Type the output. Okay, so that's gonna be the character. We're only printing a character, and it's gonna be the character at index 3. Well, the character at index 3 is I, because we start counting at 0. So it's gonna be an I, followed by the enter. Yeah, let's do the hardest one. Whoa. So we got Barrett and Cloud, and it looks like we're just gonna concatenate the two together. And so we get Barrett, Cloud, enter. Yes. All right. Oh, good. Here's another one. Type 2 statements. The first reads user input into a person's name, and the second reads user input into a person's age. Use the int function. Okay, so type 2 statements reads name and age. Use int to convert the age to an integer. Below is a simple output given. Oh, sure. All right, so we're supposed to type asking the user. First of all, we're going to ask the user for a name. So, and the variable name has got to be that for this to work. So the person name, I'm going to copy, paste, equals, and this is just asking the user what the person's name is. Input. Just like that. Nope, no second. And then we got to ask the age. I copy this and say this is equal to input. But if I just leave it like this, it's going to be the age as a character string, and I don't want an age. I don't want to leave it as a character string. I want to convert it into an integer. You know, I'm teaching the same chapter in Java in my other class, and I've set up my schedule, my recording schedule. So just before this class, I'm teaching that class, and you know, this particular thing that we're doing, it's conceptually easier in Java than it is in Python. It's probably the only thing that's conceptually easier in Java. But anyway, I can get to that maybe later on. Anyway, so that now we have the person's age, and what are we supposed to do? Is that it? This might be it. Well, very good. Oh, we got another challenge here. Okay, write 2 statements to read in values from my city, followed by my state. Do not provide a prompt. Oh, right. Do people like oftentimes want to tell the user what your program is asking for, or is the user just supposed to guess? Well, I guess they'd rather have the user just guess. Okay, I'm being sarcastic. So assign log entry to current time. Oh, I see. Okay, so I'm printing out log entry, and I'm this is the current time, and I'm going to read in values for my city. I'm going to read in values for my city, copy, paste. and it's going to equal something. I'll get back to that. And then I got to do my state. Equals. And that is it. Current time, my city, and my state. It's got to be current time, and then my city, and then my state. Okay, so my city is just oh, and then I got it. Okay, so I'll do this. So it's just input, and then the next one is input, and then I have to assign a value for this. Equals. I've got to start out with current time concatenated with a plus a space, looks like, concatenated with a my city, concatenated with I got to put a space there, concatenated with my state. And that's it. Let's see if this works. Lo and behold. All right, now we are in this chapter. This is a pretty good chapter because here we are quickly going over all of the basic types that we're going to learn. Next, we're going to learn about lists. Then we're going to learn about tuples. Then we're going to learn about sets and dictionaries. And those are the main ones. Oops, dictionary basics, didn't mean to do that. And then here's a nice summary of them, and that's nice and interesting. And then after that, and then converting between them, and then after that, down here we go into much more detail. But it's like, so because we're covering these different types at this level early on in this chapter, it's going to make it, when we start to cover them down here in more detail and learn the intricacies and how to use them in fancy ways and why, this is a complete set. We don't have to, this covers everything that we'd ever want to represent, pretty much, actually. Yes. So that's what we're doing here. Okay, so we've covered numbers, you know, floating point and integer, and that was covered up here in chapter 2, I'm sure. And then now it's lists. Okay, so lists are they are the closest thing to an array that Python has. And so it turns out that in Java, okay, there's arrays. We'll learn the unique advantage of arrays versus array lists. It has to do with how quickly it takes to reference a particular element in the list. So anyway, so list basics. We start out with the concept of a container, and so it's a container. I guess it would be thinking of when it's surrounded by these square brackets. Square brackets are important because we use curly brackets for other things and regular parentheses for other things. So here's a list. It's got 2 elements. It's very similar to the referencing the elements and so on. It's very similar to strings, which is why we conveniently go right into lists right after we cover strings. Okay. So so there are these elements, and so you first have to create an empty list. You have to create an empty thing that's going to be able to have these containers. And so you do this by just, this is the statement. My list is going to be your list, and here you're saying that to create a new instance of an empty list, And or you can, when you define the list, you can just put the elements in there. So here we're defining this list right off the bat with 3 elements. The first one is a string, and the second one is a floating point number, and the third one happens to be an integer. That's okay. And then, and it's what's built into Python is you run this, and this makes sense. So this is going to print out the names list just like this. Okay, that's a built-in property of lists. Anyway, it's not at all this easy in any other language, and this is unique to Python. You don't have to do anything. You just say, I want to print my list, and Python knows exactly what you mean and decides on a format for you. See, look, I mean, it's not because I typed it in exactly. Look, when I do this, it's still going to output with the spaces. Okay, so you know. And well, anyway, so let's make sure you go through these. You get points for these. Access elements of a list using indexing expression. This is just like strings, except for this is not a string where you want to output a character. This is a list where you want to output the first element in the list. And this list, it consists of 3 things. Now, it's not those words. What it is this is a variable, so it's whatever the value of this variable is. Well, what is the value of this variable? Well, it better be defined up above. Sure enough, it is. And so the value of this variable is 3,900,000, and this one is 2,400,000, and this one is 1,850,000. So those are the values of these variables. So when you create a new list, it's a list because it's got these braces, these square braces, and things in the middle separated by a comma, variables. You can put literals. In other words, you could just put an integer there, or you can just put a string in there with quotes, or you can put variables. So anyway, so this is going to print out the 0th one, the first one. So this is going to print out like that, just like strings. All right, what's this? Oh, I'm supposed to say what it is. Well, I would say that it is Gus, comma, Bob, comma, Joe. Gus, Bob, Zoe. All right, so that's this one. And uh-oh, what did I do wrong? I thought I could put a comma. I thought I could put a comment over here. I can't? That's nuts. All right, I'll do that. I thought a comment was a comment. There we go. So if you're going to put a comment on the same line as a regular statement, you use the hashtag. If you want to comment out a bunch of lines, then that's where you use this double thing. Anyway, so that's that. Here we are referencing, append. Okay, so that's how you add stuff onto the end of a list. Oh, good. List methods. See, you can do a lot more stuff. A list, we learned this later. A list is you can change a list. You really can't change a string. When you change a string, you're actually throwing out what was there and creating a whole new string to replace it. But with a list, you can just add stuff in the middle, and it's the same list. You know, there's no copying over to make a new one. And the computer geek terminology for that is a string. You can't change it, so you cannot mutate it. So a string cannot be mutated. A string cannot mutate, so it's immutable. A list, however, can change. So a list can mutate, and so we say a list is mutable. So those are terms that you're going to hear later on, and pretty soon you're going to not have to think about what they mean. All right, so you have these methods. There's a pen that just adds an element onto the end of the list. A pop will remove an element probably from the beginning of the list. Oh no, pop, you throw an index in there. Oh, I see. Pop, this, okay. The argument for append, the argument is the actual thing that you want to tack on to the end of the list. You want to add one element to the list on the end, and that's how you do it. And this is what you're going to add on. Pop returns something, and this I is the index of the element that you want to return, and then it removes it. It pops it out of the list. And then remove does the same thing, except for the argument is not the index. The argument is the value. So with remove, it goes along the list until it finds the first element that's this value, and it removes it. So that's what that does. So make sure you understand that. So it's mutable. That means you can have list things on the left side, write statements that performs a desired action. Update the price of the second item, house prices, to 175. So I think we can just do this. House prices of 1, because we're talking about the second item, equals this. Is this right? Yeah. Add a price to the end. Well, that would be house prices. Dot append that. So this will stick it on the end. I think. Oh, okay. Okay, so you can do those. Sequence type functions. So our built-in functions that operate on sequences, so the list, like lists and strings. So these operate on on either a list or a string. You know, they're quite different, but conceptually they're very similar, and they're so similar that there's these common methods here. And I think that the reason they call them sequence type functions is because they aren't really, when you use them, it's not like you want to know the length of a list, you say len parentheses, and then the list inside. It's like the int function, where int, the way you use the int function is the argument of the function is the you know, the source of what you're taking the integer, or the source of what you're creating an integer, the source of what you are creating the integer from. See, that's different from saying list.len paren paren. Okay, that's so when we want to know the length of a list or the length of a string, you use it this way. This produces a new list by concatenating 2 on the end of one. This will find the element in the list with the smallest value. And all the elements have to be of the same type. And then the next one is the maximum. The next one is the sum of all the elements. So they all have to be numbers for you to do that, because it has to make sense. And then this is how you get at the index of where this value is in this list. So this is going to return an integer. When you use this in an expression, it's going to be replaced by an integer, and that integer is the index of where this value is in the list. And this will count up the number of occurrences. We're going to use this count. There's a so anyway, we'll get to that. Using sequence type functions and lists. Okay, so here, like, you want to know the length, how many there are. So this is how you'd use it. How many house prices do we have? And so this is going to return there are space. This is a number because it's a number. That's this number here for prices in the list. And then the cheapest houses, they're all the same. So you can do, okay, so this is how you can create a list, and it's this with this appended onto it. So anyway, this is pretty obvious. Statistics, so you read up a bunch of scores, you're able to write them all out. Or you're able to say how many midterm scores there were, how many final scores there were, that's this. And then you're able to calculate the number of students that took the midterm but not the final. Yes, you know. Anyway, so this, and you use the min function, the max function. So, you know, you can run this and see what the result is in this particular case. Okay, that makes sense. Oh, look, a challenge. Let's see. Let's do this one. Times. Oh, we got a lot of time. I don't want to. Oh, we clipping through this very quickly. List basics. Ooh, geez, I'm spending too much time on lists. Okay, I'll do this one. What is the value of the length of user ages? 1, 2, 3, 4, 5, 6. 6? Yeah, great. Well, you can do that one. All right, tuple basics. Okay, so tuple is another type, and it's pronounced tuple or tuple. You can pronounce it any way you want to. It's similar to a list, but it's immutable. That means once it's created, cannot be changed. The tuple does not mutate. A tuple is also a sequence type, so and it supports length, it supports indexing, and the other sequence functions. A new tuple is generated using comma separated values and with parentheses around it. Note that printing a tuple always displays surrounding parentheses. So you can define a tuple like that, and you know, this will print out the tuple, like just prints it out like that. Same as with a list, but you can't change the middle. You know, you can't have you can't index an element of a tuple on the left-hand side of an assignment statement like you can with a list. You can change the value of an element in the list, but you cannot change the value of an element in a tuple. All right, what is this? We're supposed to initialize the tuple teams with as these. Okay, so I'm gonna go, I'm gonna get rid of this, and I'm gonna put the parentheses there, and I'm gonna take this, and I'm gonna copy it, and I'm gonna put it inside here, and I'm gonna paste it in there, and I'm gonna get rid of this and I'm gonna see if this works. Well, what do you know? Okay, named tuples. So I guess you can name tuples. A named tuple allows a programmer to define a new simple data type that consists of named attributes. So a car named tuple with fields like car price, car horsepower would more clearly represent a car object than a list of index positions. I see. So it's a way of naming the positions, naming the indexed elements of the tuple by their position. So I guess this is printing, so this is how you print it. So you have to import this. You have to import the ability to do it. And then here you're defining a tuple, or you're defining a named tuple. Okay, so this is like, it's like you are, it's like you're declaring a tuple. And then this is how you, no. Here you're declaring the structure of a tuple. You're declaring that there's going to be this tuple. I'm going to call it car, and I'm going to call it car, and this tuple, it's going to have 5 elements in it. And the element at index 0, I'm going to name it. I'm going to name it make. And at index 1, I'm going to name it model. And 2, 3, 4. So that's it. And then when we create, then when we use this structure to actually create a tuple that's got values. I mean, this thing doesn't have any values. This thing just says what we're going to name the values when we do make a tuple with values. Here we're going to actually make a tuple. This is how you do it, a car type, and this is a positional declaration here. The make is going to be Chevrolet, the model is Blazer, this is the price, horsepower, and the number of seats. Okay, so these are named tuples. Create a new address object house, where house street is that, house city is that, and country is this. Okay, so I guess I would go house equals address parentheses this comma this comma this. I think. Does that look right? Let's see. What does that car one look like? Yeah. All right. Let's see if this is right. Ah, very good. Okay. All right, what's this one? I'm supposed to define the structure of the tuple. So I guess I do, I'm sorry, I gotta cheat. I'm gonna cheat. I just go up here. Let me grab this. Let me grab this thing here. Copy. And I'm gonna put it down here. Let me just put this like this. And so it's player, it's gonna be named tuple. And I gotta put player here. Player. And we're gonna be calling it name, number, position, and team. And get rid of this. That's all I need. And create the named tuple, a player. I don't need this there anymore. I'm just going to comment without. Can I comment this out? Not going to let me comment it out. What do I do? Get rid of it? Maybe they want me to take this and put it here. Oh, okay. And well, then I'll just get rid of this. Okay, so this is what it looks like. 2, 3, 4. Okay, let's see if this works. All right, very good. Okay, set basics. It's 216. Okay, sets are they're unordered. They're not ordered, so that means you can't use the index thing. And unique. That's the other thing. They're unique. You can't have any duplicates. Elements are unordered, so in the set we do not have a position or an index, and they're unique. No elements in the set share the same value. Okay. And when you define a set, you use these curly cues. I can't remember if sets are mutable or not, but I don't think they are. I think they're immutable. Can you? Oh, no. Okay, we'll see. A set can be created using the set function, which accepts a sequence type iterable object. And an iterable object means you can sequence through them. A list or a tuple or a string, those have indexes. Those elements are inserted into a set. A set literal can be defined using curly braces with commas separating set elements. Note that an empty set can only be created using the set. Okay, so no, a set obviously has to be mutable because you can add stuff to it, add elements to the set. But when you're defining an empty set, you got to use the set function, and you cannot just say cannot just put two empty curly braces like you can with a list, because how is it? How is a tuple defined again? Parentheses. Yeah, tuples parentheses. And it's immutable. And so you would never define an empty tuple and then add to it, because the tuple is immutable. So you have to define the tuple the way the tuple is, and then you can't change it. So it doesn't make sense to define an empty tuple. and then add to it. But for a set, it does make sense. Okay, the reason you can't create an empty set using just put empty curly braces is because that's how you make an empty dictionary. So when you are defining a dictionary, use the curly braces also, and you'll see that. All right, here we are creating a set from a list. So it's a bunch of names. And notice Ron is there 3 times and Alba is there twice. Hema and Musa are only there once. So when we create the set, no duplicates, and the order doesn't really matter. See, so now there's no duplicates. So the duplicates got rejected. All right, okay, well, these are set methods. Find the length of the set. You can update a set by adding elements to it. No, you can update a set by adding another set to it. You can update a set by just adding a value. You can remove a value. You can pop a random element from the set, and you can clear the set. Since it has no order, has no index, it just returns a random element. Okay, this is a example of modifying sets. Okay, here's a challenge. The top 3 most popular male names of 2017 were those 3 names, according to babynames.com. Write a program that modifies male names by removing the name and adding a different name. Oh. Okay, so you start with a set like this, and just like this, and you're going to read in one name, and you're going to read in another name, and the first name better be in the set, because you're supposed to remove that name, and then you can add this other one to the set. So you got to use the remove and the add, and it's just add and remove. Okay. So your solution would be male names dot remove name to remove, and then it's male names add name to add. That seems pretty simple. Let's see. Okay. Python set objects support typical set theory operations like intersections and unions. And if this is the first time you've seen intersections and unions, you're going to see it a lot more. So it's easy. The intersection of 2 sets is the elements that the 2 sets have in common, and the union of 2 sets is where you take the 2 sets and add them together. Of course, duplicates are removed. A brief and then so you can do this is intersection, and this takes the intersection of 2 or more sets. You can have as many sets as you want. And it returns a new set containing only the elements common between this set and all of these sets. And this is the union. You take this set and you union it with all these sets, and it comes up with a set. This is a difference where the elements in common are removed. The elements returns a set containing all of the elements of this set that are not found in any of the other sets. So you start out with this set, and then you start removing all of the elements that it has in common with this set, and then remove all the elements that it has in common with this set, and you go all the way down the line, and at the end you're only left with, in set, you're only left with elements that are not in any of the other sets. Symmetric difference returns a set containing only elements that appear in exactly one of set A or set B. So that's a little different. Oh, so it returns all of the elements that are unique to one set or the other. All right, so this sort of helps you understand that. Go through these in this class. All right, so what is this now? Okay, take the following program includes fictional sets of the top male and female names. All names that contains the top 10 male and all the top 10 female. Set neutral names that contains only names found in both, and specific names that contain only gender specific names. Okay, so those are the ones that are not found in both. They're only found in one or the other. So it does not, so it will not contain any neutral names. Neutral names, what a name. All right, so we want to define all names, and that's going to be equals like okay, all names, we're going to do all names equals set dot something. No, let me go back up here. Let's see. Here we go. We're going to do a union. Are we going to do all? I think we're going to do all three of these. Let me just copy these things here. Copy. And let me just do this. I'm going to paste it right here. And I'm going to first, all names is going to be the union. It's going to be the union one. And intersection is going to be the ones that are common in both. So that would be the neutral names one. And specific names would be the ones that are not in both. So this goes here and this goes here. This goes here and this goes, wait a second. That's not right. I'm going to use male names for the first term. And then I got to use female names for the union, female name, intersection, and female names difference. Except for I don't think it's difference. I think it might be asymmetric difference. So what is that word? Symmetric difference. That's the word. That's the word I want. I think it's that. Symmetric difference. Okay, let's see if this is close. Hey, very good. All right. Now we're going to learn about dictionaries. And let's see, I remember in this class, I'm just covering the challenges. Yeah, in the class that I video where you guys come, I do the challenges, show you how to do all the challenges, and then I make separate videos on the actual I make separate videos on the labs. Okay, so I have a half an hour to finish up the challenges here. Okay, very good. Okay, so a dictionary is different. It's the most, I think it's the most powerful. It's a container that describes associative relationships. There's by the dictionary type, dictionary associates. A key is the term that can be located in the dictionary, such as the word cat, and the value is some data that's associated with the key. So, and we use the curly braces to define a set or define a dictionary, which is why we can't just use it that way to define a set. So this says we're defining a dictionary called players, and this is the key, and this is the value associated with that key. So we have these key value pairs. So when we print out the dictionary, it looks just like this. And we can refer to well, here's creating a dictionary, caffeine content in milligrams, and these are the keys, and these are the values. So we look up things by their key. So we would look up Red Bull. We would not look up, 270, but we can still, we can look up 270, but normally you think of this as this is the key, and this is the value that's associated with that key. So this just prints out the same thing again in a different format, in a nice format. All right, so okay, here we go. Here's how you reference elements in a dictionary. You reference them, the index here. You don't put an index. There's not an index. It's not an integer. It is a key. So this little dictionary here says that the keys are apples is one of the keys and oranges is another key, and there's values associated with them. And so we're calling it prices. So if we want to know what the value associated with apples is in this prices dictionary, that's how you do it. So when this thing prints out, it's going to print out the value of apples here, and then lemons is not defined. So that's why we get this error, key error. It's a key error. There was no key in this dictionary called lemons. Adding, modifying, and removing dictionary entries. The delete keyword is used to remove entries from a dictionary. You say this. That will remove the entry whose key is papaya. So let's say you have and when you want to add a new entry to a dictionary, you just do it this way. You put the name of the dictionary, the key that you want this new value to be associated with, and then the value. And to modify, it's just what you'd think. You would have on the left side, you would be referencing an element in the dictionary that already exists. So you're not adding a new one, you're modifying one that already exists. It's the same way of expressing it. It's just that this one already exists and you're going to store a new value for whatever was there before. And if you want to delete Rachel, you just say delete Rachel. See, it's like this. Here we're deleting some prices, we're deleting this element out of the prices dictionary and so on. And so this makes sure you understand this. Which statement adds pairs to the dictionary? It's this one, not this one. That's an interesting way to think of it, though. This would produce a key error because you're trying to delete limes out of the prices dictionary and it's not there. So this would produce a key error. All right, here, oh, look, a challenge. Let's see. Write a statement to add the key Tesla with the value USA to car makers. Modify the car maker of Fiat to Italy. Sample output for the given program. Okay, so you got these this two element dictionary here, and we want to add to car makers. We want to add Tesla. So I'm going to say Tesla equals USA. And we want to modify Fiat, car makers of Fiat is equal to Italy. And is that all we need to do? I think so. All right, well, that's pretty good. What's next? 3 point. There's no challenge activity. There's no challenge in 3.6. Common data types. Okay, this is interesting. Click through this. Additional practice, there's nothing there. Aren't even any participation activities. Time is it? 20 minutes. Okay, there's 3 more sections and they each have participation activities. So let me go through those. Type conversions. A calculation sometimes must mix integer and floating point types, for example. Okay, so there's the implicit conversion. Didn't we just talk about this? No, that was in the other class. When it's really obvious, then that's implicit conversion. So you don't have to specifically say, well, I'm going to add an integer to a floating point number. Oh, by the way, I want the result to be a floating point number. You know, that's obvious. If you add an integer to a floating point number, it's obvious that you want the result to be a floating point number. So you don't have to bother converting the integer to the floating point number first. Okay, really, you're not supposed to mix, yeah, but there's some cases where you can mix. Yeah. For example, here you're mixing an integer with a floating point number, but it's okay. There's an implicit conversion that goes on because this is represented inside the computer much different than 1.0 and 1 are represented much different inside the computer. So there has to be a conversion that takes place before you can take advantage of the microprocessor's add instruction. So anyway, if you're down at the microprocessor level, then you actually do have to convert because otherwise it won't make sense. So anyway, that's what this is talking about. But when you do have to specify this, you use these functions here, an int function. No, don't you? Yeah, yes, that's what you use. It's different. And okay, so let's another challenge. Is this the first challenge? There's the one up here? No. Sorry if this is buzzing by. It's kind of fast. Okay, let's do this one. What is it? Number equals 1, new number equals number times 4. Print new number. Don't these things have no? So it's going to be 4. Enter. That right? Okay, let's do number 3. .0 enter. I have a floating point number, which is that, and I'm going to add it an integer. I'm going to multiply it by an integer. Well, I'm going to implicitly assume that that's going to also be a floating point number. So that's why I did. That's why I answered it that way. And oh, what did I do wrong? Oh. Yeah, 3 times 1 is 4. So it's going to give me another chance. Number is 4 times 3. So what's floating point? Same thing, but what's 4 times 3? It's 12, right? Yes. 12.0. All right. Let's do 5. Oh, we want to float it. So it's going to be 2.0. Yes. All right. Well, you can do the other 3. Let's do this one. Typecasting. Computing the average owls per zoo. Okay, assign average owls with the average of the owls per zoo. Print average owls as an integer. For example, when you do this, 1, 2, and 4, and you want to find the average of that, and then the output is an integer. Okay, so average owls is this. Okay, so I think you're adding them up and then dividing by a number. So that's okay. Okay, so average owls, AVG owls, owls equals, I want to add up num this plus this, except it's a B, plus this, except it's a C. Okay, that adds them all up. That's going to be an integer. And I want to divide it by 2. I'm sorry, 3, because there's 3 of them. So I'm going to say divided by 3.0. And that should make it be a floating point result. Let's see what happens when, let's see what the answer to this is. Okay, so that's the right answer. I'm going to see what happens when I put just 3. Because it doesn't matter. Maybe it doesn't matter because it's a floating point number. All right. Oh, yeah, makes sense. Oh, no, never mind. All right. Typecasting, reading and adding values. Assign total owls with the sum of that plus that. Oh, typecasting. Okay. Look, these are strings. and I want to add them up. So I say total owls equals, it can be integers, I guess. Sure, why not? Int of num owls A plus int of num owls B. I convert them to integers, and then I add them up and store them here. So I'm pretty sure that works. Okay, what's next? Binary numbers. Yes, we got some challenges here. So it's binary numbers. Normally a programmer can think in terms of, base 10 binary. Okay, we got to convert, Okay, so binary, decimal, and it looks like this. So anyway, this tells you how that this explains decimal number representation. This is binary number representation. In decimal, it's these positions are, this is 2 times 10 to the 0, and then 1 times 10 to the 1, and then 2 times 10 to the 2. Yeah, you've seen this before. Make sure you understand this. What is this? Set each binary digit for the unsigned number below 2, 1, or 0 to obtain the decimal equivalents of 9, then 50, then 212, and 255. So what are we supposed to do? Note that 255 is the largest number. So how do we do 9? That would be 8 plus 1. So 8 plus 1 is 9. How about 50? 50 would be, let me turn these off. 50 would be 32 plus 16 is 48 plus 2 is 50. And 255 is all ones. So anyway, now why are we learning this now? Create a binary number. Match the decimal value in binary. What am I supposed to do? That's it. Oh, correct. I don't get it. Let's try it again. Match a decimal number in binary. Check. What's this one? I assume you're going to be getting different. So, okay, check. Oh, this one. 7. Then, that's 7. All right. So anyway, I think yours is going to be different. This one also has a challenge in it. String formatting. Oh yeah, you should learn this. Is this time? String formatting. These are different ways to write output to output. Different ways of output using the print function, and one of them is using F strings. F strings. So the way F string works is you'd have F quote, and inside you just have a sentence, or you have what you want to output, but the numbers the variables that you want to output, you just put those in curly braces, and then the variable name inside. So this is going to start out by printing whatever the value is for number, which in this case is 6. And then it's going to print space burritos cost space $sign. And then it's going to print whatever the value is for amount. This is space burritos cost $sign, and then it's going to print out this amount. So that's how this F formatting works. Additional F strings. All right, so if you really do want curly braces, you got to put curly braces twice. Okay. It's weird. I don't know when you'd ever use that. I'm sure there's not going to be any labs for that. Let's see, what does this do? This is outputting a string. Oh, this is how to format what you're outputting. The colon something to format what you're outputting. This is the decimal number. This is a binary number. This is a hexadecimal number. This is using the E format. This is a floating point. This is just, this is how you limit. This is how you limit the number of digits to the right of the decimal point. And this is how, if you want it to be 3 digits, I guess, with leading zeros or something. Leading zero notation. Wow. All right. So make sure you understand that. Let's see what we have here. Oh, this is only supposed to go to 245, isn't it? Well, I'll just finish these 2 challenges and then I'm done. 3 challenges real quick. Ooh, okay, 3 challenges real quick. This one is formatting with F strings. Hi, my name is. So it's going to print out this, copy this and paste it there, enter, but instead of $, instead of curly brace name, this is replaced with Ron. Very good. Let's do 5. Okay. We're printing this out. Copy, paste, and we're printing, doing an enter, and this is going to be replaced with this. And it's going to be with 2 digits to the right of the decimal, floating point number, 2 digits to the right of the decimal point. It's already 2 digits to the right of the decimal point, so I don't have to do anything to it except for just replace that. And so I think this is the answer. Yeah. What's the last one? Ooh, this is pretty cool. We have the number 13, and we're going to print it out this way. Copy, paste, enter. Okay, now this is going to be the number printed out in binary, I guess. And that, what's 13? It's 1101. That's 13. And then D is a decimal number, I guess. So it's just going to be 13. And then this is 13, but 3 digits to the right of the decimal point. So it's going to be 13. Oh, I didn't mean to do that. It's going to be 13.000. That's what I think. Let's see if this is right. Okay, I'm just going to check. D is decimal number. Yeah, D is decimal number, B is binary number, and F is fixed point notation. Oh, when it's defaulted, when you don't say anything, it's 6 digits. Okay, so anyway, let's see if this is the right answer. All right. Okay, what's this one? Printing an F string. Write a single statement to print that. Note there's no space between the comma and the user number. Okay. Print F. User word. User number. All right, let's see if this works. Not bad. All right, one more. Start. Select the most appropriate replacement field definitions. The math class has num students. All right, is this right? Yeah, what's next? Loan rate, borrower's name. Borrower's name's loan rate is this, because 0.05, really you wanted to say 5%, 5.0%. And this is going to multiply it by 100. Okay, so I think this is probably it. Oh no, it's right there, shoots. Okay, it's going to give me another chance, right? Borrower's name, the loan rate is this. This can't be right though, because well, I guess this is it. All right. Okay, what's next is practice help aid. Okay, yeah, there's no activities. There's no participation or challenges in here. So you can look at that. All right, it's 2:56. And so I will make a couple of three short videos before next time, covering these three labs here. And does anybody have any questions? All right, great. So I will see you next time. Thanks for watching.